Hi, and welcome to this week's infamous tale of a lonely titanium mug. A camping mug. Camping mug without a lid. And a friend of mine asked me, hey, I've got a lonely camping mug without a lid. Could you make me one? Because I slosh my coffee all around. So I grabbed a chunk of aluminum, and voila, turned it down, and we have a fairly nice lid that fits really snugly. It's not watertight, but it's pretty close. It only drips a little. Then he was taking the lid off and on a few times and found when he rubbed his finger along it, hey, I'm getting aluminum residue. That's no good. So he washed it in the dishwasher and he got an oxide layer over the whole aluminum lid. And that oxide layer is fairly abrasive resistant, but still, if you can see in the light, it's wearing off. Partially because the top of this titanium mug, I think it was pressed into a mold, is pretty rough. So it's abrading the aluminum. So I've gotten a piece of titanium off of a website, well, off of eBay, from a group called Sacklin Metals. And they charge 22 bucks a pound for cutoffs. And I think they actually made this piece, cut this piece for me at 3/4 of an inch, which is what I asked for. And was a really good deal, so check them out. Ordinarily, titanium's out of the reach for a lot of people, but if you want to try and experiment with it, these guys are pretty reasonable and they're very quick shippers. So we're going to be making a second lid, much like the first one, except this time out of titanium so it won't wear. Thus, 2 lids, 1 cup. So the first step of turning this titanium piece into this is going to be to face both sides. Then my order of operations is kind of important because of how I have to hold it, because it's such a small, thin, it's going to have such a thin outside edge. So what I'm going to do is, after I face both sides, I'm going to hollow out the majority of this inside portion first. Then I am going to take off the outside bit and then finish the back. Or maybe I could finish the back when I'm facing it so that I don't have to come back to that. See what we can do to make it efficient. We're currently an interrupted cut, and I may have to change the angle of this cutter to avoid having the outside part of the jaw run into this. So we're currently cutting this without lube. And I'm going to try and do the whole thing dry, but if I start seeing glowing bits, then we're going to have to change things. I've avoided using coolant or lubricant. I use lubricant, brush on lubricant, but flood coolant or mist coolant, I've avoided using that because I'm worried about rust. Okay, so we were only touching one tiny little part there. So that's some pretty small stuff. And I'll give a demonstration later of why you need to be careful with titanium. There we go. And you just witnessed why with titanium coolant is necessary. So we started with a little bit of coolant, which is just spitting it all over the place. The joys of coolant. Not enough coolant. Let's try it again. So I've increased my feed rate and I've slowed the lathe down. I'm currently at 180 RPM. I was 440. I'll tell you what, this titanium is incredibly hard stuff. I was having a problem with the tool cutter being pushed away from the work, and even with my slide lock, my longitudinal lock. So I increased the feed rate, took a bigger bite, and actually that's a nice finish. So we're going to flip this over and face the other side. And try and clear these chips that are not breaking. I do not have the right inserts for special materials like this, so I'm using a steel cable insert. Which means I'm probably going to wipe out the tip on it, but that's all I've got. So this is 20 thousandths depth of cut, feed rate of 9 thousandths a revolution, RPM 180. So even with high feed rates, this stuff finishes really nicely. It is beautiful material, extremely hard to work with. I always thought, oh, okay, people are talking about how hard it's to work with. I really didn't have the proper feel for it, but I'm starting to get one, and I haven't done anything complicated yet. For God's sakes, all I've done is try and face this thing. So let's chamfer this. Since this is the side we're going to hollow out, chamfering it's not a big deal. I just want to break the edge so I didn't cut myself as I'm reaching in there, because actually we're going to take this material off. So, alright, let me bring you back. We got to drill a hole in the middle next and try and hollow this out. I have no idea how the hell this is going to work, if at all. This is a great learning experience though. So, among other things, a little bit of coolant is coming out of the pipe on the left. The one on the right is just air, but that'll help cool the material and the drill bit. And perhaps we may need a little more coolant. Hopefully this won't block your view too much. That does not sound good. I don't think it's liking this drill bit. Try another one. Different style drill bit for deeper cuts. One's doing much better. Feels like it took the edge right off of it. So the problem seemed to be lubrication before. So now we're going to go for a 1/2 inch. I just wanted to make it so that the center of the drill bit wouldn't have to cut, so that's why I did the smaller one first. So last time it seems like I was fighting against lubrication. Okay. So now I'm going to add a little coolant, and we're going to attempt. I think I was having better luck in some ways using lubricant over coolant, but we're going to try both. So we're going to go with the coolant first, and we've got to take a ton of material out. So we're going to get started. So I guess we'll try, see if it can handle 50,000 steps of cut. I'm gonna have to clear chips in this small one here first, though. That actually worked out all right. So 50,000 steps of cut was doable. I got a whole lot of passes to go. I'll bring you back. Trying 100,000 steps of cut. Chip breaker's working and it seems to be going all right. There's a much larger boring bar, 100,000 steps of cut, with a feed rate, excuse me, of 9 thousandths a revolution. Everything, but I have the feed rate from 9 thousandths a revolution to 4 thousandths a revolution. I was getting some pushback at the end. The cutter would be pushed back when he was flexing a little bit. I was pushing too aggressively. .329, and we want to go to 4.6, so we're 17 thousandths. There's a little bit of bounce, but we're going to take the last bit. Not that this is a critical measurement at all. Okay, we're at final width. We need to clean up the inside a little bit. So next we're going to turn this down to the final outside dimension that'll fit in the cup, 3.516 more or less. We'll go for 3.550 initially, and I think what we're going to do is we're going to rough cut this approximately the size and walk it in slowly. Having a problem getting chips to clear. Doing 50,000 steps of cut it. So we got a long way to go. Here's another pass. I'll do one and I'll bring you back. It's kind of messy too because I'm getting chips all over the place in a big rat's nest. So I'll show you another one. I'll bring you back when I'm closer. So I'm getting close to getting this down to the final size here. Taking smaller and smaller bites each time. Because now the material's thin enough it might deflect a little while I'm cutting it, then bounce back. What a bird's nest we get going. I think I'm going to come in and clean up the face here. All right. Then we're going to go to the back side and do the same cutter on the back. Oops, wrong way. We got to go backwards. Alright, we're done. Got to take some sandpaper and just take some of the burrs off of this. But then we're going to flip it around and we're just going to put some grooves in the top piece and chamfer these edges, and then we should be done. Use the bearing to straighten this guy. Matter of fact, let's go to slower speed still. We don't need speed for this. This is as slow as I get. So you just push gently until the bearing is consistent. 75,000 depth of cut. That'll be it right there. Let me clear this off. And I do. Clear out the chips, and we'll do the last one. I decided we'll do 3. Alrighty, and we're done. Just got to sand this a little bit because there's a little bit of burrs on there, but it's got a nice gripping edge, so that's nice. And we're done. So thus ends the saga of 2 lids, 1 cup. The original aluminum lid and the new titanium lid. The original aluminum lid I made looser because I made the diameter the same as the outer lip, so you really don't have a easy way to get purchase on it. The titanium one, I left the full 4 inches with left 1/8 inch all the way around, plus it's stiffer, and these are sharper, so you can actually get this off pretty easily. Not so easily one-handed if you push it way in, but pretty easily otherwise. I learned a lot during this project. Working with titanium is extremely challenging. If you go too fast, I normally go around 440 RPM, that was way too fast, and as you saw spectacularly, the titanium caught fire. Coolant may have solved that, like flood coolant, probably mist coolant didn't do anything for it. It still had the same problem. But the real solution was to slow it down to around 140 RPM, which is where I did almost all the work at, which makes it slow work. On top of that, even at that slow RPM, I ended up damaging several of the carbide inserts I used. So that also was learned. Now, granted, none of my carbide inserts are designed for working with titanium and exotic metals, but you know, I wasn't taking big bites, 50 thousandths, up to 100 thousandths for the heavier duty one when I was facing. But still, I had problems with the smaller inserts at 50 thousandths depth of cut when I was trying to push too fast. So I found about 9 thousandths a revolution with 50 thousandths depth of cut was okay, and the cutters lasted for the project. Probably have to flip them now. I'm sure the guys out there with experience are laughing, going, we could tell you a whole lot. You're just a mere novice, which I am. So I'm learning. I learned a lot this project. Hopefully maybe you learned something too. All of my inserts are steel inserts, no exotic metal inserts, as I said previously. Thanks for watching. Hope to see you next time. Hope it was useful for you. I learned a lot.